Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video. And today's video is about another interesting topic in short range wireless communication subject. We're going to see UWB technology. In this video, we will see introduction to UWB, what are the characteristics of UWB, and what are the important applications of UWB technology. UWB is wonderful technology where you have very latest applications like AirTag, UWB digital key, all those things. We will see all those things in this particular video. And this video is about an introduction video for UWB. First, what is UWB technology? And we already know that we already seen in previous videos about Bluetooth, Wi-Fi, Zigbee, all are short range wireless communication applications, right? So UWB technology is also a short range RF communication where you have a lot of advantages when compared with other wireless technologies, right? So far we have seen Bluetooth, and we have seen Wi-Fi, and we have seen Zigbee, right? And now you're going to see about UWB technology. First, what is UWB technology? Ultra wideband technology. From the name itself, you can understand it has a wide bandwidth, right? And this UWB is going to be a very powerful technology in wireless communication. Why I say it is a very powerful technology? That's because when it comes to wireless communication, right, bandwidth plays a very vital role, correct? Bandwidth is very, very important. Uh, when we speak about this short range communications, Bluetooth, Wi-Fi, Zigbee, all this, all these short range communications have a specific frequency range, right? A specific frequency band. Especially most of them works in this particular frequency, that is the ISM band 2.4 gigahertz, right? And it has a very short bandwidth, right? And but in UWB technology, we have a wide range of frequency. That is, the bandwidth of UWB is very wide. That is, it covers from 3.1 gigahertz to 10.6 gigahertz. You can see 3.1 to 10.6, which where you have a very wide bandwidth. When we say wide bandwidth, that plays a very important role in wireless communication. That is, when the bandwidth is high, when the bandwidth is huge, that means you have very good capacity, right? When we have a large capacity, which means data rate can be uh, very fast. That is, you can able to send more number of data, more amount of data, and also the speed data rate can be increased to a great extent, right? That is the greatest advantage of UWB, and this is an RF communication technology, right? Like Zigbee, Wi-Fi, even in Bluetooth. Like right now in UWB, what we are going to do is we are going to have only short range communication. We're going to cover only 100 to 300 meters. But it is a very powerful technology because it covers short range, wide bandwidth, and apart from that, it consumes very low power. It consumes very low power, which makes it very, very vital for many applications like logistics, manufacturing, and healthcare. You have lots and lots of applications. And apart from this important advantages like wide bandwidth, uh, low power consumption, it also have a lot of important characteristics. That is, it overcomes the drawbacks of narrowband communication. We have a lot of disadvantages in narrowband communication. All those drawbacks is overcome by with this particular technology UWB. Right? We will see one by one. As if now you understand what is UWB, and you can see these are the important features: high data rate, low transmit power, penetration capability. This is very, very important. Where this particular technology, you have the center frequency is very low and the low power spectral density as well. So what it can do is it can able to penetrate the walls, materials, and so it can be used in radar applications, military applications. This plays a very vital role in radar applications. And apart from that, because of wide bandwidth, you can also do a precise localization. That is possible. it can able to communicate and position in the same technology that is possible in UWB, right? These are the important features, right? And another important feature is it is very immune to multipath, very immune to interferences, right? And it cannot be easily detectable, right? And you can see these are the applications. Just a short summary: radar communication, sensor networks, rack networking, consumer electronics, location and positioning, right? And one important challenge in UWB is small interference with the existing wireless standards, right? There are chances that interference can happen, but UWB is very immune to interference. We will see that, and you can see these are the advantages which we saw just now. Large bandwidth. Because of large bandwidth, we can able to send a huge amount of data, and the data rate also will be very high. And you can see it is low cost and low transmit power. Whenever it comes to short range communication, low power plays a very vital role in wireless communication. Power is very important, right? Any gadgets which are going to design, right? Any gadgets which we have, power is very important. How far it can withstand power. So if you have a technology that is going to have that is going to consume only low power, then it will be a very boom for any particular wireless devices. And UWB is one particular technology which has already been integrated in iPhones, like latest iPhones. Every iPhones have U1 chip, and you have a lot of other gadgets as well. Apple AirTags, everything has U1 chip, where because of its low power and because of accurate positioning, we are using UWB chip. And you can see it is robust in fading, and it has penetration and possible capabilities, right? And if you when you see the frequency range, apart from the narrow bands, if you say, like as I said before, all the short range communication has a specific frequency range, right, as a specific frequency band. But here in UWB, it starts from 3.1 gig, starts from 3.1 gig to 10.6 gig. You have a wide frequency range. And because of that bandwidth, you can see here the capacity, data rate capacity here, 8.1, it is 1 kbps, whereas in Bluetooth, it's 30 kbps, and it's 11A, it is 83 kbps, whereas here we can able to reach up to 1000 kbps per meter square because of wide bandwidth, right? And why we choose UWB, why we have to go for UWB, because of all these advantages. All these are drawbacks of narrowband systems where multipath, I have already explained in the first video about short range communication, what is multipath communication, right? And definitely that multipath fading is a very important drawback in narrowband system. And but it is overcome in UWB, and it is very insecure. Narrowband can be easily detected, but UWB removes that insecurity because it cannot be easily detected or jammed by any particular devices, right? And in narrowband, it has poor range resolution, but here in UWB you have wide range of bandwidth, right? Wide range of frequency. The bandwidth is very high, and that is why we can able to use it for tracking applications where narrowband systems cannot be used, right? And in narrowband, we have a limited data rate, whereas here we have the data rate is huge because of wide bandwidth, right? So these are the drawbacks of narrowband system, which is overcome by UWB technology. And by this time, you will understand what is UWB, why we go for UWB, correct? And now these are some other coexisting wireless technologies which can create an interference with UWB, right? These are the frequencies where you can see Bluetooth, it works in 2.4 gig, right? And WLAN, this is the main interference source for UWB, right? And you can see the UWB ranges from 3.1 to 10.6 gigahertz, but in WLAN, it covers within this particular, when it comes with this UWB band. So it can be a potential interferences. And apart from it, we have other interference sources as well, where you can see the Wi-Fi, the range is 5.1 to 5.35, and WiMAX, that is connection-based Wi-Fi, it ranges from 3.65 to 3.7, and maritime navigation radio, that covers from 9.0 to 9.6. These are some potential interferences. So whenever we design an UWB devices, right? We have to be careful with this particular interference sources, right? We have to bypass these interferences, right? And these are the notable UWB applications where UWB plays a very vital role right now in healthcare, logistics. In logistics, we can able to track the vehicles where it is exactly. Even in manufacturing industries for tracking the products, right? We can able to use it, and also like it is very accurate than GPS. Like whenever GPS is not possible in indoor location localization of application, we can use UWB, where you can see positioning, geolocation, localization, or the important applications, right? Where in multipath environments and in very obscure environments, whenever the environment is very tough to monitor, we can use UWB, right? And also in communications, where it is to be very effective for short range, high range communications and high multipath environments, right? RF tagging as well, and radar sensor in military application, anti-terrorist applications, rescue applications, we can use UWB, right? And these are some few diagrams which shows the importance of UWB. Where right now in laptops we have a Bluetooth, Wi-Fi, we have separate antennas for all those things, right? But if we have, if we can able to integrate U1 chip, where we can able to integrate U1 chip in your laptop, we can able to incorporate all this applications. That is, we can able to connect all these devices wirelessly, so that we can easily take printouts, we can easily take do transfer of files, everything can be done very easily, right? So the UWB enabled laptop can able to transfer without needing any particular wire or all those things, right? So you can see these are the devices which can be connected wirelessly with the laptops. And another important application is military, as I said. Here it has the penetration capability, where we can able to penetrate through walls, and we can able to sense the intruders, the terrorist present behind the wall, and we can able to take action. That can be done using UWB radar, and it can be used in UWB application. In military applications as well, where we can able to create a short range network, and we can able to communicate, and we can able to do a rescue operation or attacking operations, everything. And coming to state of art, that is latest UWB applications. UWB finds in applications almost in all fields right now, whereas in smart home, health and fitness, smart city, connectivity, industry, and also automobile industry, mobile and accessories, and security. And some notable applications which we started using right now is Apple iPhone, where you have UN chip integrated, and you have Apple iPhones, that is 11 and 12 series, everything is UN integrated chip. Apple Watch series, Apple AirTags, that works only with the UWB technology. And smartphone application, digital key, where digital car key, right now it is used in high-end BMW cars. You will see all those applications here. So you can see this Apple AirTag. This is the U1 chip which I'm speaking about, which is integrated with your iPhones. And Apple AirTag is a wonderful application where we can able to track our devices, books, keychains, whatever thing, right? If you forgot anything, like if you feel if you misplace your uh, bags or books or something like that, you can have an AirTag in that, and you can able to connect that AirTag with your iPhone, and you can able to keep tracking that AirTag, and you can easily locate that particular device, right? And you have a lot of applications with the AirTags. You can Google it and you can check what are the applications with the AirTags, and the only technology behind this AirTag is UWB, where you have a UN chip integrated in it. And this is another advanced application where we have UWB digital key, where you can able to turn on the door, like the central locking system. You can even start your car using the UWB digital key, where you don't need a physical key. Instead of that, you can use your mobile to control using this UWB digital key. And apart from it, in healthcare, right, in medical field, it plays a very vital role, right from tumor detection till patient monitoring system. We have UWB. You can see in this particular diagram, UWB tumor reduction. I just show what are the glimpses from various papers where you can see UWB tumor reduction system, UWB neural recording system, and you can see UWB capsule endoscopy that is possible, and UWB MRI scan soon. The MRI scans will be replaced by this UWB MRI scan, and patient monitoring system where we can able to monitor the patients. Touchless monitoring is possible using UWB. We don't want to touch the patient. We can monitor the patient without touching them, which can play a very vital role, like during pandemic situations, and respiration monitoring, and in body area networks, organ monitoring. All these are important applications of UWB, right? And I would like to say that I have done my PhD in UWB technology. And my work is this one where we will detect prothrombin time using UWB antenna. We have a lot of works to be done, but as of now, you can see here, I've used this antenna where using the antenna, I can able to detect the prothrombin time of a human being, right? This is the antenna which I have designed, and this is just to show how UWB can be helpful in medical field, right? And this is the fabricated antenna which we work. And today, what we have seen is we have seen what is UWB technology. I've just given the introduction. What is UWB? Why we go for UWB? What are the advantages? What are the applications? I believe this video will be very useful for you, my dear students. Thank you very much.